Now we have question number 2. Question number 2 says, a manufacturer makes 2 different models of cell phones. 20% of the cell phones are Model A, and the remaining 80% are Model B. It is known that if a randomly selected phone is of Model A, then the probability it has a flaw in the memory card is 0.02. It is also known that 2.8% of all phones have a flaw in the memory card. What is the probability that a phone has a flaw in the memory card if it is a Model B phone? So, what's the first step? The way I like to do these things is first, we write out in mathematical notation what we know and what we want. So, one of the pieces in the question said, it is known that if a randomly selected phone is of Model A, then the probability it has a flaw in the memory card is 0.02. So what that becomes in mathematical notation for probability is that given A, so we have the probability of flaw given A equals 0.02. And the A is on the right-hand side of the vertical line because that's what's given. That's what we know has already happened. So it is known that if a randomly selected phone is of Model A, then the probability it has a flaw, so probability flaw given A equals 0.02. The next point was, it is also known that 2.8% of all phones have a flaw in the memory card. Well, that's simple. That's just talking about all phones. So that becomes the probability of a flaw equals 0.028. What is the probability that a phone has a flaw in the memory card if it is a Model B phone? So that's the question we're trying to answer. It's saying we know it's of Model B, so the B is to the right of the vertical line. The vertical line, once again, means given that, or given that we know already, or given that B has happened for sure, what is the probability of flaw? And that's the question we're trying to answer. Okay. So, how are we going to go with doing this? Well, when we have a complicated conditional probability problem, I think it's incredibly helpful to draw a tree diagram. Okay? And so the tree diagram always starts out with 2 branches. And how do we set up the tree diagram? Well, our final goal, like we said a couple of screens ago, is that we want to know what the probability of flaw given B is. Right? And so it's saying that we know B, what's the probability that since we know B, what's the probability of a flaw? So because B is the first thing, because it's on the right-hand side of the given sign, we know that the first stage of this tree diagram, the first branch, has to be whether it's Model B or Model A. So we say this is stage 1. So the first branch we have is either it's Model A or it's Model B. So then we know, well, if Model A, Model B is the first stage, then flaw versus no flaw is stage 2. And so we can think about it, we have a branch that says, if Model A, then what's the probability of a flaw? What's the probability of no flaw? If Model B, same thing. And now we need to fill in the numbers that we know and we don't know. Recall how we label the probabilities. There's a very repeatable method that we use here. We start, because Model A and Model B is the first stage, the value that we're going to assign to the branch from Model A is just the probability of A, and the the probability we assign for model B is just the probability of B. Okay. So then the next stage becomes, given that we know A, because we're already in the model A branch, right? So everything that you're seeing on the screen from flaw and no flaw follows from model A. So they both are the probability of flaw given A or the probability of no flaw given A. Similarly, in the B branch, we already know B happens. So we have flaw is the probability of flaw given B, and no flaw is the probability of no flaw given B. And now we want to fill in these probability terms with actual numbers. So we've removed the probability signs, and now we can plug in the numbers that we're given. So model A, like the question told us, is 0.2. And whenever you have a branch, the other side of the branch is 1 minus the other one. So we know model A is 0.2, therefore model B is 1 minus 0.2, which equals 0.8. Okay, so now we go up to the model A branch. We're told that the probability of flaw given A is 0.02. Therefore, the probability of no flaw must be, the probability of no flaw given A must be 1 minus 0.2, which equals 0.98. Now, the probability of flaw given model B, that's what we're trying to figure out. That's what the question is asking us. So, we just give that a variable name. We'll just call it x. And if the top branch there is x, then the no flaw branch must be 1 minus x. Okay. So now what do we know next? We also know that the probability of just a flaw is 0.028. And remember that when we want to find the probability of flaw, we need to find everywhere where it says flaw, and we need to add those values up. So the probability of flaw is 0.2, because that's the model A, times 0.02, because that's model A with a flaw. And then we add model B, which is 0.8, times x. So now we have two equations, probability of flaw equals 0.028, and we have a formula for probability of flaw that's 0.2 times 0.02 plus 0.8 times x. So we can just set them equal to each other. So we say 0.028 is equal to the probability of flaw that we have just above, and then all we do is solve for x. When we do that, we find out that x is equal to 0.03. And so now we're done. We have the value for x, the value that that the question was asking for, which is the probability of a flaw given model B. And so we know now that the probability of a flaw given model B is 0.03. And we are done. All right, I hope you learned something from this video, and I will see you all in tutorials this week. Thank you so much.